Hello guys, welcome to the next section on the Arduino workshop by IEEE. In this session, we'll be learning more about the serial monitor and how to print strings in the serial monitor and how to input values into the serial monitor. So for that, first we are going to write a program to make these two LEDs blink alternatively. How this is going to work is that first the red LED is going to blink 5 times and then it switches over to the yellow LED which also blinks 5 times and the loop gets started all over again with the red LED blinking. And while we are at it, we are going to print statements like which LED is currently blinking, and we are also going to note down the number of blinks. So let's analyze the circuit. We have connected pin number 13 to a resistor which is connected to the anode of the red LED and which is connected to the ground. You can see that it is connected to the ground. The same thing is applied for the yellow LED which is also connected to a 220 ohm resistor which is connected to anode and is connected to the ground. So now let's get into the coding part. So we are going to declare some variables and assign some values to it, which will be used in the later part of the program. I have assigned red pin as 13, which is the pin number of the red LED, and the yellow pin is assigned the value 12, which is the pin number connected to the yellow LED. And the red message and yellow messages are strings that we are going to print in the serial monitor when the red LED is blinking or the yellow LED is blinking. And now let's get started with the void setup. So in the void setup, what we have done is like we have assigned pin modes. So we have assigned pin modes for both the LEDs. You can see that the red pin, which is pin number 13, is assigned as output, and the same is applicable for the yellow pin also. And we have also given serial.begin and given the baud rate 9600. And the void setup part is complete. Now let's go on to the void loop part. In the void loop part, first we have to analyze what we are going to do, what we need to do in order to make the program run correctly. So first we need to make the red LED blink 5 times. So for that I am going to type in a for loop I equal to 0 and I less than 5 and I plus plus. You can either write I plus plus or you can write I is equal to I plus 1. Both are correct. And I'm going to start the for loop, and inside the for loop I'm going to write digital write. I hope you remember what a digital write is. I'm going to assign it high. After that, when the red LED is in on position, we need to pause for a second, maybe less than a second, and then make it stop, make it in the off position. So for that I'm going to put a delay of 200 milliseconds, and then I need the red LED to go to the off state. So once the LED is in off position, we need it to pause again before going back to the on position. So we are going to place another delay of 200 milliseconds, sorry. I think this is enough for the red LED part, and we are going to copy this for the yellow LED also, and we are going to paste this here. But we need to change the names to yellow pin. So let's run our code and check whether there are any errors. So this tells that I was not declared in the scope, right? We also need to declare the variable I. Before using this in the for loop, we have to assign the, so I'm going to just assign I. So you can see that the red LED is blinking 5 times and the yellow LED is blinking 5 times. So now let's look at the serial monitor. As you can see, the serial monitor is empty. If we need the serial monitor to print which LED is currently blinking and the number of times it has blinked. So let's modify this code. Let's stop the simulation first. First, what I'm going to do is I'm going to increase the time to 500 seconds so that you can actually count the number of blinks. 500 milliseconds. Sorry. Now what we need is that immediately after the red LED is in the on position, we are going to print the statement. For that, we use another function called serial.println. You can actually use serial.print or serial.println. The difference between those two are that if you use serial.println, after the statement you are going to write, there will be a new line. So the next statement, when you write it, comes into the next line. But in the case of the serial.print, all printed statements are in the same line. So I'm going to use serial.println here, and I'm going to print the red message. So I am going to give the variable name red message in the serial.println, and I'm going to put a semicolon. So after the digital write happens, immediately after that serial.println happens, and also I'm going to print number of blinks equal to, and I'm going to add blinks equal to, and then I'm going to add another print statement. Here I'm going to use println, and I'm going to give the value I. So you can see that even though 3 print statements were used, only 2 lines are being formed at a second. You can see that once I clear it, you can see that 2 print statements are formed at a second. This is because I used serial.print in the second line. So after the number of blinks, it prints I in the same line itself, so that I have a continuity in my sentence. Now let's copy the statements for the yellow LED also. Instead of red message, we need to print yellow message. I think there is no more corrections to make, and let's run the simulation. You can see that the print statement of the red LED is working fine, and yes, the yellow LED's print statement also is working fine. So our program runs successfully. But you can see that blink is from 0 to 4. This is because I took the initial value of I as 0. To change that, I have to put I plus 1 here. So now let's run it again and clear the serial monitor. Now you can see that it starts from 1 and ends at 5. So our program is working just fine. So we have learned how to print strings in the Arduino serial monitor. Now let's look at how to input values into the Arduino serial monitor. So what can we change in this program to make it some more user friendly? You can see that we already have determined the number of blinks a LED is going to make. So what if the user could decide that? Okay, let's do that. So we are going to ask the user how many times the LED have to blink before switching to the other LED, and then we are going to assign it in place of 5. So let's assign another variable called number of blinks, which is going to be an integer. I'm going to go with numblinks for short. And then we have to ask the user through the serial monitor. So I created a print statement asking how many times do you want the LED to blink. So now we have asked the user, but there is no way we can read what the user is typing. So let's add another code for that. So we can't put a delay here because we can't expect the user to write the answer as fast as they can. Some may take hours to write the answer, some may let it play for a little bit and then answer, some may take seconds to answer. So we can't actually put a delay here. So we have to wait until there is an input from the user. For that, there is another function in Arduino. This is called serial.available. What this does is that it returns a value. It returns 0 if there is no input from the user. Otherwise, it returns a 1 if there is an input from the user. So how we are going to use this is that we are going to put it in a while loop. So what I have done here is that I have declared a while loop. Inside the while loop, I put the condition as serial.available equal to 0, such as if there is no input from the user, I have to go on in a loop forever. I have to wait till there is input from the user. If there is an input from the user, the serial.available value will not be 0 anymore, so that it will break the while loop. So after breaking the while loop, we have to actually store the value from the serial monitor to a variable before using it. So we have declared a variable here called numBlinks. So we are going to use it here. There is another function in Arduino called serial.parseInt, which will read from the serial monitor and store it in the variable declared. You can actually search the internet and find keywords to replace parseInt. Like if you want to read a floating value or if you want to store a character or a string, you can actually search for the keywords and find it. And now the number of times the LED should blink is saved in numBlinks. And now we have to change these 5s in both these loops because they are the predetermined value which we created in the earlier program. We have to change that to numBlinks. So I think our code is complete. Let's run it. There is an error. I forgot to use the closing parenthesis and the semicolon here. So let's run it again. There's another mistake. I used the question mark after the double quotes and that's the problem we had. So now it's finished and let's run the code again. And now you can see that the code is working fine. There is no error statement. So let's go on to the serial monitor and you can see that it asks me how many times I want the LED to blink. So let's type in 6. So you can see that it is blinking up to 6 times rather than the 5 we have placed earlier. So we can change the value, like we can stop the simulation and start it again. And you can see that it has asked me again how many times I want the LED to blink. So now I want the LED to blink 3 times each. So I'm going to send 3 and you can see that the LED only blinks thrice before changing the color. So I hope you understood how to input values into the Arduino serial monitor, and do explore more functions of the Arduino serial monitor and how to input various other variable types in the Arduino serial monitor. Hope you enjoyed the video. Thank you.